Pick a card, any card. Actually, just pick up all of them and take a look. This standard 52-card deck has been used for centuries. Every day, thousands just like it are shuffled in casinos all over the world, the order rearranged each time. And yet, every time you pick up a well-shuffled deck like this one, you are almost certainly holding an arrangement of cards that has never before existed in all of history. How can this be? The answer lies in how many different arrangements of 52 cards, or any objects, are possible. Now, 52 may not seem like such a high number, but let's start with an even smaller one. Say we have 4 people trying to sit in 4 numbered chairs. How many ways can they be seated? To start off, any of the 4 people can sit in the first chair. Once this choice is made, only 3 people remain standing. After the second person sits down, only 2 people are left as candidates for the third chair. And after the third person has sat down, the last person standing has no choice but to sit in the fourth chair. If we manually write out all the possible arrangements, or permutations, it turns out that there are 24 ways that 4 people can be seated into 4 chairs. But when dealing with larger numbers, this can take quite a while. So let's see if there's a quicker way. Going from the beginning again, you can see that each of the 4 initial choices for the first chair leads to 3 more possible choices for the second chair, and each of those choices leads to 2 more for the third chair. So instead of counting each final scenario individually, we can multiply the number of choices for each chair, 4 times 3 times 2 times 1, to achieve the same result of 24. An interesting pattern emerges. We start with the number of objects we're arranging, 4 in this case, and multiply it by consecutively smaller integers until we reach 1. This is an exciting discovery, so exciting that mathematicians have chosen to symbolize this kind of calculation, known as a factorial, with an exclamation mark. As a general rule, the factorial of any positive integer is calculated as the product of that same integer and all smaller integers down to 1. In our simple example, the number of ways 4 people can be arranged into chairs is written as 4 factorial, which equals 24. So let's go back to our deck. Just as there were 4 factorial ways of arranging 4 people, there are 52 factorial ways of arranging 52 cards. Fortunately, we don't have to calculate this by hand. Just enter the function into a calculator and it will show you that the number of possible arrangements is 8.07 times 10 to the 67th power, or roughly 8 followed by 67 zeros. Just how big is this number? Well, if a new permutation of 52 cards were written out every second, starting 13.8 billion years ago, when the Big Bang is thought to have occurred, the writing would still be continuing today, and for millions of years to come. In fact, there are more possible ways to arrange this simple deck of cards than there are atoms on Earth. So the next time it's your turn to shuffle, take a moment to remember that you're holding something that may have never before existed and may never exist again.